Refrigerators are very simple. The same idea that runs a refrigerator basically is the same that runs your air conditioner or any device that cools. So it's all about losing energy and adding energy, okay? And that's what we're all about here. So I had you draw, and I will come back to this in just a minute. I had you draw. Let me flip the screen here a little bit. I had you draw a rectangle. And on this rectangle, I wanted you to label the four corners. In the bottom corner, I wanted you to label it compressor. If your corners don't coincide, that's fine. Okay? I'm going to label the four corners. Evaporator, expansion valve, compressor, condenser. Refrigerators, just so you know, used to be made with a refrigerant. It's a special liquid, and it was called Freon. Okay? Yeah, it was in cars for a very long time. It was an excellent refrigerant. Okay? It worked well. It was really cheap to make. The problem is that when vehicles or refrigerators used to get old, they would just cut the pipes. If you look here, they would cut the pipes on a device like a refrigerator or a freezer, and then they would let the Freon escape into the atmosphere because it evaporates very quickly. Well, the issue there is that it hurts the ozone layer. Really, it's actually really, really, really bad for the environment. So nowadays, they use different types of refrigerants that have been made by us to be more environmental friendly. And you might have seen this. I don't know how many of your parents do their own air conditioning treatments on the vehicle. Anyone in here? Okay. Well, if you walk into Meijer or Walmart or an auto parts store, you can go back to the automotive section and you can find in the aisle cans of refrigerant. It's usually called R134A, okay? So that's a refrigerant. So what you should first know is that there is a refrigerant liquid inside a refrigerator. So there is a liquid, and it oftentimes takes on both gas and liquid states of matter inside the refrigerator, okay? So coursing through our refrigerator is the refrigerant. Okay, we will just call it R134A. Now, there are different refrigerants, and some refrigerators use different ones. This is a refrigerant that they use, and the air conditioner in your car uses a very similar cycle. Your air conditioner in your car has to have a compressor, an evaporator, an expansion valve, and a condenser. This is what is required for any sort of cooling process. Okay? So first thing we do is we compress the liquid at the compressor. Okay, so at the compressor, and this may seem kind of silly, but let's write it anyway. At the compressor, we compress the refrigerant. We compress the refrigerant. A compressor. There is. Yep. It's usually, just so you know, it's usually inside like the dashboard or just at the back of the back of the engine, right on what they would call like the firewall. Right. The compressor is a pretty sensitive. When you move a refrigerator, what you're supposed to, like that refrigerator back there. When you move a refrigerator, you mix up the refrigerant inside the compressor. So you're supposed to let them sit for a period of time before you turn them back on. Okay. So anytime if any of you ever have to move a refrigerator, Okay, if you have to move it upstairs or it bounces around a lot or you don't move it smoothly, you're supposed to wait like an hour before plugging it in to let everything kind of settle, okay, and just to make sure everything is okay inside the refrigerant system. So we have a compressor and we compress the refrigerant, okay? This is done using electrical energy, so that's why we plug our refrigerator in. Our refrigerator, okay, is literally plugged into the wall so that we can use the compressor. Okay, so this is where, and if you look at the back of the refrigerator, okay, I'll pull it out a little bit. I think we should be able to see it. Okay, what's that? Would that affect it being cold? Yeah. Let's go ahead and take a video here. All right, thank you. All right, so here's our refrigerator. We're going to go ahead and pull it out. You hear that? That's the compressor. It's kind of bouncing around in there a little bit. Okay, so down here at the bottom, okay, if we look at the bottom of the refrigerator, you will see this device. If you look closely at it, you would see that there are wires going to it. And on the side here is the little electrical housing. Okay, this is the compressor. This is the device that compresses the refrigerant liquid. Now, you will also notice that there are different fittings coming off from it, okay? So you'll notice some fittings, they're fitting there and there and there. You will notice that the electrical cord is right here going into this housing. This electricity runs this compressor. This compressor is hot, okay? It's very hot. So what it does is it compresses the refrigerant. From there, the refrigerant will go out into the evaporator, okay? It's okay. So let me draw your attention back to our diagram here. Let's look at what happens here. Okay. Or excuse me. Sorry. The compressor sends the liquid to the condenser. All right, so we compressed it. It's now dense. We send it to the condenser where it is a liquid. Okay? Usually at this stage, it has a lot of heat, hence the reason that it is red. So we go from the compressor to the condenser, so let's draw an arrow. And let's draw this down here. We're going to go from the compressor to the condenser. The condenser is a place where the refrigerant becomes a liquid. This is pretty important. The refrigerant becomes a liquid. And usually during this stage, the condenser is going to be very hot, okay? Because at this point, usually the liquid has a lot of energy, okay? It has a lot of heat energy that it's pulled from inside the refrigerator out, okay? So the compressor goes to the condenser, and the condenser is hot, which means that it's going to give off energy. Okay, it's going to give off heat energy. So what I also want you to do is on the inside of your rectangle, I want you just to draw some squiggly lines with arrows. Okay, and you're going to write gives off heat energy. So if you ever feel the back of a refrigerator, it's usually quite warm, okay? Because you have a big condenser. How many of you have a refrigerator at home that has that big coil on the back of it? Okay? The big coil on the back. It kind of looks like it's a big piece of metal. Okay. Usually older refrigerators have it. Newer refrigerators now are coming so that they're kind of enclosed so you don't have access to that. Okay, we've gotten refrigerators that are quite a bit more efficient than some of the old ones. Or even some from even 10 years ago. All right, so we have a compressor, goes to the condenser. It's hot at this point. It's going to give off heat energy. Okay, and then we go from the condenser, the liquid, the refrigerant goes through an expansion valve. Okay, what this is it's not like what you think a valve as in a valve that you turn a knob. This is a valve that takes a liquid and all of a sudden allows it to expand really quickly. What happens here is it goes through drastic cooling. Let's draw some information here. First of all, the expansion valve changes the liquid to a gas. Okay, so we have a liquid here. What's going to happen is we end up with a very cold gas here. And so what happens when we go from liquid to gas is that there's an expansion and cooling. It's a liquid in the usually it comes into the compressor a gas. It's compressed, put out into the condenser where it becomes a liquid. Okay, we'll go through the whole cycle when then we've done explaining each piece. But the expansion valve changes it from a relatively warm liquid to a very, 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 very cold gas. Expansion which results in cooling. Okay? How many of you have ever held a CO2 cartridge? Okay, a CO2 cartridge. Okay. How many of you have ever poked a CO2 cartridge and then let it all out very quickly? Has anyone ever done that? Does anyone know what happens to a CO2 cartridge when all the CO2 escapes very quickly? What happens to it? Yeah. The cartridge doesn't necessarily shrink. Yeah. It gets very cold, so much so that it actually forms frost on the outside. When you allow a gas or a liquid to expand rapidly, okay, it causes the temperature of that liquid to drop drastically, okay? So think about it this way. Expand rapidly, temperature drops drastically. Expand rapidly, temperature drops drastically. So when we have this refrigerant, it's gone through the condenser, it comes up here as a liquid, it's mostly cooled off because by the time it gets here, most of the heat it's given off has escaped into the room. This is relatively lukewarm by this point. Okay, then the expansion happens when it goes through the expansion valve and it causes the refrigerant to expand rapidly and cool drastically. And so what happens is it drops to a very, very, very cold temperature. Kind of like an air horn. It gets cold on the outside. Yeah, that would be a great example. When you squeeze the air horn, you're letting the gas out. It expands out into the room very quickly. As a result, there's less gas in the horn. It expands and the can gets cold, okay, because there's expansion which is taking place. When gases expand in a space, they usually cool. Okay, so we have this cooling effect. Okay, so we started at the compressor. We compressed the refrigerant using electrical energy. That's the reason we plug our refrigerators in. We go to the condenser where we becomes a liquid, but this is where it's giving off lots of heat into the room. Okay, it then goes through an expansion valve which causes the gas to expand quickly, cool drastically, and then we take it to the evaporator. Okay, and that's where the gas refrigerant is inside your refrigerator. Okay, the evaporator, you'll notice it's blue in this diagram, is where the coolant goes through the inside of your refrigerator. If you look inside this refrigerator, you'll actually see the evaporator.
Mr. Jackson, we like Domino's.
Okay, so here's a refrigerator. And inside this refrigerator is this box, okay? And if you look closely, and it's kind of hard to see, the box is right here. It's at the top. They used to call these ice boxes, but this is actually the thing that is cooling the refrigerator down. It has ribs in it, okay? It has ribs, not the meat ribs, but as in like a bumpy surface. Ladies and gentlemen, this is like a hose. It is tubing. It is piping. And what's going through it right now is a refrigerant that is in the gas state of matter.
What do you mean?
Gas. As in like air.
No, but like, it's putting in gas or taking out?
No, we're not thinking of fuel gas. We're thinking like
I know,
water
air gas.
vapor, air gas. So there's basically really cold gas particles inside there right now.
So they're like shooting out little things of nitrogen.
No, they're not shooting out anything. They're just inside there and they're really cold. That's it.
How did they?
We pumped them in there.
That's why that.
I thought you said it wasn't pumping in.
Stop talking. Isabella, we are moving cold gas into this evaporator right here. We are pumping it in from the back of the refrigerator, pumping it in one side, and it's going out the other. And as it goes through that, it's very cold. So as it moves, kind of like, we might transport air through our house through heat ducts. You can think of this as a duct. It's pumping really cold air through there. It's so cold that it's absorbing energy from the inside of the refrigerator, like from the milk and from the water, okay? And then it's taking it out of the refrigerator.
And it's just separated by like a little plastic box.
Say what?
It's just separated by a little plastic wall.
Yeah. It needs to be in contact with the air. It's got to make the air very cold by removing energy. It absorbs energy. Then it takes that energy to the compressor. So let's look at the compressor.
Is that why like your tires get lower air in the winter?
That's a different topic. Okay? This is different. Okay? So now we have the evaporator inside the refrigerator, and the evaporator is pulling heat energy out. Okay? It's absorbing any energy. So like when I open that door and warmer, more energetic air flowed into the refrigerator, now that air is in there, this refrigerator is working, it's on, to remove the energy I just added and pull it out. Okay, so here's how it does that. It sends the energy to this device down here called a compressor, which is very hot. Okay? And the top of the refrigerator is very hot. Okay? The compressor turns that really cold gas into liquid. Okay? It turns it into liquid. Now, a couple of warnings. Okay, a couple of warnings. If the room that you're in is hotter than the condenser, the heat cannot leave the condenser, and you end up with a problem. You're pumping heat out of the refrigerator and you have nowhere to put it. And so actually what happens is your refrigerator can work and work and work and work and work, and eventually it can stop working, or so usually this process is the back of your refrigerator is usually warmer than the room temperature in your house. Okay? Second thing is if you leave your refrigerator open, it won't cool down the room. Why not? Some people always thought, well, let's put 5 refrigerators in here, open them up, and it'll cool the room down. Why is that not going to work? Okay, because the back of the refrigerator is giving off the heat that's been pulled out. So really what's happening is if you put all the refrigerators in a room and open them up, the back of the refrigerators are going to give off heat, which is going to go right back in the refrigerator, and it's just going to work and work and work and work and work to do nothing. Okay? You're just recycling the same energy over and over and over again. However, if you were to build refrigerators into the wall of your home so that the inside's faced in and the backside's faced out, we call those window air conditioning units. That's what they are. You ever felt the back of a window air conditioner? It's hot. It's a refrigerator, but we've decided to put the back end of it out the window and the front end of it inside. And then that's where a window air conditioner comes from. It's the same thing. It's basically a refrigerator. So you could, if you can't afford a window air conditioner, cut a big hole in the wall on the side of your house, buy a full-size refrigerator, and open the door. Okay? It'll do the same thing. Might be a little bit more obnoxious. Yeah, and if you want it warm, turn it the other way. Okay? Oh, I need a little heat in here. Let's turn our air conditioner back around. We'll cool the outside and pump the heat inside. You could. However, there are more efficient ways to heat our homes than turning window air conditioners around. Okay? The refrigerators in your homes, ladies and gentlemen, like the air conditioning units are the same way. That big box that sits outside your house, okay, which part do you think that is? Is it the compressor, the condenser, the expansion valve, or the evaporator? Drew. It's the compressor and the thing that gives off lots and lots of heat energy. This is pulling energy out of the area you're trying to refrigerate. So this is not outside. It's the condenser. Your compressor and condenser are outside, so that you take refrigerant, put it through your furnace usually, cools the air, then you blow really cold air throughout your house. All right? But in the process, you've pulled heat out of your house. We've got to send that heat somewhere. So we send it outside to the compressor and condenser, but then usually the fan kicks on to blow the heat out of that unit. Okay? The problem is on really hot days, they have to work and work and work and work and work because usually your house heats up and it's harder for the air conditioner to get it cold and colder and colder and colder inside the house. Yeah.
So the refrigerant runs through the furnace?
The refrigerator, yeah, there's an evaporator inside your furnace. It's just a coil that you blow air over. It's very cold.
So they've made it so your air conditioning kind of work hand in hand.
So your air conditioner and your heating can work hand in hand. Now, in hot water heat houses, you can't do that. So in hot water heat homes, if you have central air, they've had to put in a whole separate unit to cool your house because you can't use water pipes. Not unless you want to freeze them, but then that's a problem because then they burst. And of course, then you have a big mess on your hands. Yes, Casey.
So that's why in like really hot days there could be chunks of ice on the air conditioner.
Chunks of ice inside your air conditioner, not on the outside one.
Well, a while ago, like there was a big chunk of ice on it. Like
On it?
There was a pipe and then there was a chunk.
A pipe, was it going back into your house?
Yeah.
It's because it's probably gone through an expansion valve at that point and cooled drastically. Does that make sense? Okay. If it's cold, it's gone through the expansion valve. Any questions about this? 4 steps. Compression, condenser, expansion valve, evaporator. It's a cycle. We pull heat out of a space. We then pump that heat someplace else. Okay? There's no energy lost. We're just moving energy out of a space and into another space. So actually, that refrigerator heats my room a little bit. Okay, that refrigerator actually heats my room, but it keeps the inside of the refrigerator very cold.
Or cold drip.
Yes.
Could you have a hot water heater and the forced air inside?
You can. A lot of people who have hot water heat have a forced air unit installed in their house. And what I've seen done is they usually put them in the attic, and then they run like duct work down into the ceilings of all the rooms. And so what happens is then the air conditioning unit turns on and it blows cold air, which has had the energy removed, okay, into your house through your ceiling. They usually have little holes, maybe about the size of a tennis ball, maybe a little smaller, golf ball. And they usually put them in different parts of the house so that you can have cold air pumped into your house. Because otherwise you don't really have a way to do it except using window air conditioners, which work fine, but then you need one for every room, and they're not as efficient as a big, like a central air unit.